I want to go over some basic principles about creating symmetric parts and symmetric faces or features. So here I have a construction line already drawn. If I hover and right click over it, I can set as mirror line. So now any geometry that I've drawn on the left is reflected over to the right. So if I make a very simple shape and come out of the mirror line by escape, if I now go to 3D mode, so press D for 3D mode, I now have a face. If I select the face, you'll immediately see that I have a mirror reflected plane with a mirror icon on it. If I didn't want any face linking to be created, just check the mirror plane icon to deactivate and pull as usual, or deselect the mirror sketch line prior to exiting the sketch. I can now select the face and pull on it, and let's just put it up a small amount, and there I have my first simple symmetric part. So there's a couple of ways to check there are linked associated faces. Firstly, there's a display of a mirror plane when a face is selected, and secondly, by close cursor proximity to any linked face, both faces will highlight with a texture change, which is clearly shown in any line view. So we can now move or pull in any direction, and the opposite will happen to the other face. So let's now move this face. Let's spin it around and we get that happening. Another thing we should note that we can add other features. So if we now pull on this edge to make a small face, let's just make sure, let's try to add a little chamfer. There's a little chamfer, but also the chamfer's been added to the other side, which is very good. So to further add some symmetric features, holes, notches or ribs, we have to go through a slightly different process after the mirror sketch creation to create the linked faces. Back to our solid view, let's select the top face and let's have a construction plane on there. Now what we need on that construction plane is another mirror line. So what we can do, we can project the first mirror line upwards to the new view, like so. We can select on this and we can again set as a mirror line. Now it's a solid line. It was a solid line this time, not a construction line, but I'm not particularly worried because it's not actually bisecting the part. So it's not actually going to have any effect upon, if you like, the integrity of the top face. So now let's make a single hole. As you can see, we get a reflected hole. Now, the process to add symmetrical mirror features into a body isn't particularly obvious. So before we come out of the sketch, what I'd like to ask you to do is to deselect the solid. Now come out of the sketch by pressing key D for 3D mode. Now then, bring back the solid, and when you pull this face into the solid, it's important to select only one copy of those two circles. It can only ever be one copy. So let's select one copy. Let's now cut it and pull it through. And now what we've got is a new feature. So let's select the whole. Let's move that. Well, let's pull it. And as you can see, it pulls. Let's move it, and it moves with it as well. So that's quite good. I'd like to show you some other aspects of this face association, face linking. If I select this face and also then I select the mirror plane, if I select the face again, I've only got the mirror plane selected. I can now delete that. Now what that means is if I select a face, no longer is there any face linking available across that particular mirror plane as it's been deleted. So mirror planes, if no longer useful, can be individually deleted. something else. If I pull this face, so let's pull, not move. If I pull this face and disable the mirror plane, I can pull it like so. And what that now means is that even though the mirror plane is still there, let's just show you. If I now select this face, it can be pulled independently and its previous linked face association is permanently removed. So now, even if you go back to the same place where it was, it's lost its linking. So let's undo that, undo that, undo that. Great. Now holes work slightly differently than faces. So if we select a hole and we're going to pull on the hole, if we turn off the mirror association plane, we can change its size. When we come out, unfortunately, when we come back to it, it still is associated to the hole. So we push it back to the sides and you see the other one also goes back. Now, if that's not what you require, and for me it isn't, what I can do is if I select the hole, I can cut the hole and I can paste the hole back. Okay, so we now combine. So we select a part, we select the hole, we remove the hole, and there you have it back, which means now if I now select it, it's lost any association to the other hole. One other thing, and that's moving. With moving, let's say I want to move that face, and let's set a direction for a move. So if I again disable the mirror tool, I can move it, but what's happened is it's moved, but it still has retained its association. So if I go back to this face, it still has retained its association, which basically means it could now be further moved, but with an offset, if you like. It's now got this additional offset to that linked face. So let's move it in this direction, and you can see they both move. Let's now go back and delete that association. So let's now check the mirror plane, unselect the face, and we've only got the mirror plane. Let's delete this. And I now want to show you effectively how we can restore some mirror associations. So at the moment, if I do this, there's no reflected mirror associations. So this is done quite easily, provided the part has some existing symmetrical faces about the new mirror plane. The pulling process talked about earlier initiates a face linking algorithm creating symmetrical relationship. Let's create a sketch plane on this symmetric face. Automatically, its axes are positioned to the mid-face extents. Now move it up to the smaller and non-symmetrical upper face. So that's our original symmetry plane, and the line is still there. So what I can do now, so let's just escape out from that move. If I click on there and I do set as mirror line, I can now make another set of faces. So this time I'm going to make a little square, just like this. And again, what I'm now going to do is in my structure tree, I'm going to turn the solid off, and I'm going to press D to enter 3D mode. I'm going to bring the solid back on. I'll select one of the patterns like so. I'd like you to note actually that when I select the face, see the size of the mirror plane. It's proportional to its mirrored faces. Now, as I pull cut, watch the plane expand throughout the body. This is a visual indication that if there were any symmetrical and same area sized faces about that particular mirror axis in that body, new linked associated face pairs would now be established. So after the pull cut, see the holes are now linked back together. But let's look at the side face. Oh, No association because its face area is different. Just to show you something else, you might find this interesting. That surface there, which is hopefully going to re-establish some part symmetry. The reason it does that, by the way, is because when this process is action, this pulling of symmetry into a larger part, it seems to set off a mathematical process, let's call it an algorithm, that then searches for other symmetric faces about the new sketch mirror axis. And if it finds them, it creates linked faces. But let me show you. I mean, before it didn't work because we had that chamfer on. But this time I want to add that chamfer before I pull those faces, and let's see what happens. So let's add a chamfer. It's a 0.2, I think. There it is. So let's go around. Let's click on one of those faces again, and we will just do a pull cut, as they say. And again, let's have a look at the mirror plane. And as we see, the mirror plane as a pull cut expands to the whole part. Now then, let's turn on our solid edge view. And if I now select face, look, it's established it. It's found it, and it's made it symmetrical. There you are. There you are. And there's the original. And let's just do a group select. See what happens. There you go. I want to show you that symmetry can also be about features rather than the complete part. So here I have 4 slots which are symmetrical to the length of the plate and also about the center line of these 2 holes. If I select a face, you can see I have 2 mirror axes. And if I now lasso select the side faces, you can see I have no symmetry about the outside edges. Although a simple process, local contained symmetry takes a couple more steps than previously described and will be a topic within an advanced video. I want to show you how you can get to some more information on this symmetry aspects. If we go to help resources, here we have start page and online tutorials. We also have the online help, but let's just go back to the start page. Let's open it. So up comes the start page. If we now scroll down, using DesignSpark Mechanical, if you click on this, you'll come along to our Zendesk articles on using DesignSpark. So up in the search column, let's just type in mirror symmetry. Enter. And here we have quite a long list actually, and it goes on to another list. So let's just look at articles. So here we have 7 articles, and by category what we've got them in DesignSpark PCB, DesignSpark Mechanical, and DesignSpark PCB Pro. So if we go to Mechanical, here we have 2 articles, mirror facing and objects to make symmetrical mirrored bodies. How do I define symmetry? Examples using a line or G, D, and T symbols. So if we click this first one, up comes a recent article, and within it there's quite a lot of information. So what we've got here, let's have a quick look. Amongst the other things that have been discussed in the video, there's also mirror bodies, handed pair, and what we've got quick tips and diagrams on creating ad hoc mirror face feature part. These quick tips on making mirror pair parts use standard construction and manipulation tools. These how-to tips have been included to help new CAD users. Importantly, if pulling a mirror face, as in the process previously described, The face linking algorithm will still work and face associations will be established if found. To demonstrate this re-establishing ability to link symmetric mirror faces during a pull operation, here's a pair of irregular shaped bodies with a blended spline face. So here's the spline faces. These were just created fundamentally from this spline and this spline with a blend between the two. And this was done in mirror planes, so I have the exact opposite on the other side. And it's worth showing here a fast and easy way to incorporate a blended surface into a body by using the pull up to command introduced in version 4. At this moment, these bodies are not linked in any way. So if I remove these spline faces to show you, and let's put it into a line mode, I box select, you see I haven't actually got any linked faces so far. By pulling this surface into this part, this will now produce and here's my little mirror plane icon, this will now produce face linking across the two parts. So let's pull, cut all the way through. And again you see the mirror plane expand to encompass the part. And now, as you can see, all these faces, including the spline face, is now linked to one another. So let's just do a quick little operation to see what else we can do. So let's now do a shell operation. So let's make this 0.3. Let's select this face. And there you go. Now let's round this edge. And as you can see, that fillet's being reproduced on the other side. Referring back to the article, there's more information on the creation and modifying of handy body pairs. There's also an infographic depicting the process from pair design through to individual component assembly placement with advice on the creation and the handling of drawings. 1, 2, and 3 mirror axis symmetry examples are shown, with changes showcasing the benefits of using labels in certain situations. I hope this video and article will give you enough necessary information to create either symmetric or mirror pair bodies or bodies with symmetric features. Something else I wanted to point out to you is after the search results for mirror symmetry has obviously dragged up under all types 52. Now, whilst that's a large result quantity, that reflects every topic that's ever come up in the mechanical forum, including with mirror or symmetry, for instance. This is the total quantity that has come up over many years, actually. So this one here, for instance, this would be a 2017 forum topic question, and any answer in that may not reflect the latest version 5. So it may not be entirely accurate. Other times, these questions have been answered by a user, and that may not reflect actually what support would want to add to the topic. So you have to be a little bit wary as to these results and which ones you take. Certainly any article that's been written by support, and at that particular time, there was one here, for instance, that was written back in 2017, but at that particular time it would reflect our current knowledge on any particular aspect. I certainly hope that you can find what you want, and I do hope this brief video has highlighted to you some of the benefits that could be used in designing symmetrical parts and how to efficiently go about modifying them to your design. Thanks for listening.